There were two big announcements in the last week that, if you take them combined, I think they are revealing that holodeck technology is here. The holodeck is here. What's interesting is that it's not because of some new graphics technology or even some new virtual reality hardware that was released, but rather because of what both of these technologies require. What DeepMind has done is reach an iteration of their agent that can operate within a digital environment such that it's going to be successful navigating any simulated environment. World Labs has created something that's much more recognizably the holodeck. In fact, it zeroed in on something essential to the holodeck, which is a conversation. And it's something that I've been puzzling over quite a bit, to the point that I started to build some prototypes for how I think this problem is going to be solved, or how one potential solution for solving this problem, which I think has a lot of merit in concept. So that's why we're going to dig pretty deep into the concepts along with this prototype. I'll cut to the chase. The solution I have in mind is toy blocks. So the wooden blocks I used to play with as a kid, they were good and fun because you could use them. You know, as in your infantile mind at that age, you could grasp a wooden block and stack it on top of another one and start to actually create something to affect the physical world with these primitive objects. I'll give you a quick overview of what it's like to use this prototype software, just so we have an idea of where we're heading. So the first thing we can do is start a conversation. Tell me about pretty pine forests in the US. The local agent is replying back with some information. What is it saying? Places like the Black Hills in South Dakota, White Mountains in New Hampshire. Show me a campsite of the latter. Now this is going to send off to the server, which generates the scene spec or assembles those toy blocks in the right place, giving each toy block an associated object. So it's not just cube, or, well, see the actual shapes it chose. So it's not just a cone, it's pine tree 2, implying there you go, pine tree 1 back here. And that's probably a tent and the campfire. So now we can come here. I want the tent to be a little closer to that pine tree. Because these are toy blocks, we can manipulate them. And then let's press this button. What that's going to do is send off to the server and imagine what this looks like if you really flesh out these objects. It has imagined what the scene would look like if these objects were represented in something more true to life, or expressing the full depth of graphical imagery that this AI is currently capable of. But let's say, for example, we want to spice this up a little bit. So add Bigfoot near Pine Tree 2. It'll take in the same current scene and modify it as suggested. There's Bigfoot. Let's change our perspective so that Bigfoot, yeah, let's make him look like he's towering next to the pine tree. We'll see if we can generate an image that includes our new character. Just like the actual, what were these? White Mountains. Yeah, White Mountains in New Hampshire plus Bigfoot. So that's the idea. This is the kind of imaginative play and shared context that we can have with AI using intermediate formats. I'll explain how all of this works here and how it can work for other projects as well. I think it's widely applicable. In the example you just saw, the toy blocks are an intermediate format, but there's a simpler intermediate format that we use on a daily basis, which is emojis. If you see the picture displayed on your phone when someone sends you a happy face or a frowny face or a firework, whatever it is, the image was not built on the sending device, transmitted, and then displayed. What was sent is a short code that represents that image. We'll use the starstruck smiley as an example. What your phone received was 1F929, and then your phone takes the code and knows that it's supposed to represent that as a starstruck smiley, and displays an image that's sitting locally on your phone. Your phone interpreted the code and expressed its own internal representation of what the code means. The code is the intermediate format, and the device that expresses that code can express it in any way it wants to, and indeed, different devices represent the same code differently. The code arrives on your phone and can be thought of as a description of what image your phone should show. And then it's up to your phone to actually perform that translation of turning the description into an image, and then of course rendering the image, showing the image to you. And that is a lot like how hitboxes work in fighting games. Collision volumes in games are what determines the physics and really the pieces that the interactive elements of the game need to concern themselves with, and then the graphics are a layer on top. We'll look at hitboxes deeper. Here in a fighting game, the yellow region is your hurt box, which is where you take damage. And when an attack is thrown, you get a red box, which is the hitbox. And mechanically, the game is really only interested in when those two, the hitbox and the hurt box, are overlapping, because that means damage in a fighting game. So you have the beautiful animated visuals, which are presented to the player, but invisible, very simple shapes are what is driving the simulation. So that's in intermediate format. The separation is key because the visuals are what the player is looking at, but the collision boxes are what the machine is interested in. Having those simple shapes in there as an intermediate format means that there is a common language, though, between the machine and the human player. The DeepMind project and the World Labs project are both offering up a playground or an environment similar to this one, where the user and the AI system are both engaged and have an interface, a different interface, but with the same object, which is the scene itself or the simulation itself. So the separation of an underlying format and the outward expression of that might seem like something that you're already using when you use generative AI. So for example, you could see an image and then you say that you want the airplane turned into a dragon. And most generative AI these days can understand that request and swap out those images for you. What it's doing, as I understand it, is looking at the image that's been generated, processing those pixels, perhaps with the context of the conversation that came before, but looking at the pixels that were airplane and replacing those with pixels, through reverse diffusion or whatever process, drawing out the pixels that would represent a dragon. And that is true and amazing that that's possible, but it's done by the AI model's internal representation inside the model of the whole picture. And an intermediate format is something of a different nature. And so say, for example, let's look at this camp scene where we added Bigfoot over on the right side. The fact that I can mouse over and it says Bigfoot is not involving artificial intelligence at all. What it's doing is interacting directly with the structure that the AI has provided us. And we can, in fact, open up this. What that means is that I'm not relying on an AI's black box to reach the same conclusions that I have about what this cone is meant to represent. There is 100% certainty that this cone is a pine tree. Well, it is pine tree 2. And just like the emoji code can go to express itself with different images, pine tree 2 is an object in just some structured text here, and then that object can go on to represent whatever it needs to in whatever environment or platform. To highlight the strength of having an intermediate format, let's add a second tent. As I fly around the scene, I can guarantee that we're not going to have a third tent appear out of nowhere. We're not going to have one of the tents absorb into another one. And we're not even going to lose the positions of those tents, because the image you see here is not our source of truth. The truth is in the scene spec below. If you look at a generated video and there are elements in the scene, I won't even call them objects because it's not really objects in the same sense as what we've just been observing in this prototype, but elements of the scene, elements of the pixel data that you have as your video, you will notice some strange behavior, such as people disappearing. Maybe there were 2 people and suddenly it became 3 and then removed to 1. If there's things that should be collisions, like a hand landing on a table, maybe it will pass through the table, or maybe it will blob and merge into the table. And that's because although these models are brilliant, they can still make mistakes that seem obvious to us because the representation of the world that's being ostensibly displayed with the video is not a representation that is as locked in as what could be achievable using an intermediate format. In other words, the generative model is imagining what the world looks like, but it is not locking in particular elements of the world and enforcing that consistency that the real world exhibits. Show me a playroom full of toys. And this is one of the more interesting things I found with this prototype, is that you get a sense of what this AI considers essential for a particular scene. So if I say room full of toys, I have not specified what toys I want to see, but it must make a decision about what particular objects are going to appear in that scene. I just moved the floor up. So that blue capsule is an action figure, building blocks, and a stuffed animal. I would agree that stuffed animal is required. A single crayon sits atop the desk along with a coloring book. Poster, cartoon poster. And a train track down there. That shows you the level of resolution that's required inside of an intermediate format, kind of like the code for an emoji. It doesn't take much, but knowing that there is this object, train track, and it is in this region of, whatever this is, floor, should be sufficient to have, when you go to imagine what the user should see, the high fidelity visual image, perfectly acceptable train set, even though, yeah, there you go, into a hole. Where does the tunnel go? It's a mystery. The table floating off into space. Because of how this prototype is put together, you do get errors like that, where an object will have a harsh boundary, and the AI, as it's been directed, will respect those harsh boundaries and give it its best shot. I thought it did a good job here. Show me the solar system. I worked on getting some animations going in this, and it was just too unreliable. It would have, for example, interpreted these planets as needing an orbit animation. And I've tried this particular example, and it failed spectacularly. So animation is just shut off. Interactive features another element, which you can do, and I had running in sort of a basic form. Some of these... if you clicked on them, sometimes they would do things. But it's another level of complexity, but still the intermediate format is a workable solution to doing things like that, so that you could start to build more interactive environments like a video game or a simulation, rather than just having everything pretty static as it is here. I mean, we can grab things and drag them around, but and fly, of course. Just being able to move the camera in this space is interactive, but needless to say, you could go much further, and I've taken some steps into that, but really it's just embellishing something that's already 80% to making the point, which is having an intermediate format allows you to do the types of interactions that we've been seeing with World Labs and DeepMind in their recent announcements. Let's render this scene. These scenes are not being generated at 60 frames per second or whatever you would need for real-time interactive feeds, like in a simulation, a video game, virtual reality. And that's because I'm using this as an example of showing where I think the industry is going. When you have AI generating scenes or generating intermediate formats that are translated into interactive scenes, this approach will be feasible for doing that as the hardware and the algorithms and the whole ecosystem of AI generated worlds matures. Look at these toy blocks and use your imagination for what this should really look like. And it imagines that there is a giant green box. Well, this is actually an error with how the prototype works. I don't like the bug, and I tried to fix it, but could not. But I also didn't want to spend so much time that it just delayed getting out what's really a prototype to share an idea that I've been thinking about. Let's construct a construction site. The architectural layout that I'm using here, having the client, which is what you're seeing on the screen now, and allows the interactive features, and then the server, which is the one that generated the scene spec, and also generates the images. That means that world generation is a service, and I think that can be a pretty powerful paradigm. Having an open intermediate format is a nice dream, and I hope there is something like that. But no matter how far the concept of an open intermediate format reaches, I think the principle is worth recognizing. They're all able to play in the same space if that space is, at its core, something like the code of an emoji, a format that's accessible and interactive by all. As I'm recording this video, there were two more announcements that are totally relevant to the content of it, so I have to mention first Google DeepMind Anti-Gravity, an agentic development environment for software developers. By seeing these artifacts and being able to observe and interact with them, which is an intermediate format, by the way, it can basically take care of much more of the tasks involved in being a software engineer. The other is SAM 3D from Meta. This is an extension of their segmentation work where you can look at an image and understand what's in the image. It's kind of like where we replaced the plane with a dragon. You first need to understand where the plane is in the image, which is a segmentation problem. SAM 3D automatically finds and turns those elements from a 2D image into three-dimensional models, which again is an intermediate format, and additionally it means that it can create entire scenes from 2D images. The pace of announcements in these AI-enabled technologies just highlights further how important it is for us as builders to take seriously our responsibility to shepherd these powers well into the world so that they can be forces for good. Well, that brings to mind my mission, which I will get to in a moment. So why does this matter? The projects that you've seen today are all working toward solving a problem of object permanence, which is things staying the same way in the simulated environment, whether or not you're looking at them or behaving as they would naturalistically. But in order to tackle that problem, what we're really doing is augmenting AI. And I think a useful analogy to this is a concept from philosophy called the extended mind. It's a big deal with this. It's a concept I love from philosophy anyway, and it's exciting to see it being applied to synthetic minds now. Not as a novelty, not as a curiosity, but because it's truly adding an incredibly important capability to the mind, to the digital mind. The thesis is that when there is some object outside of your cranium, outside your brain, that is storing or processing information that's being used in your thought process, then those external expressions are also part of your mind. It's as if your mind is extended into those objects. It accurately acknowledges and respects the contribution that our tools are making to our thoughts. Steve Jobs called the computer a bicycle for the mind because the human and bicycle combo is the fastest animal on land, treating it as a unit. So extended mind is kind of the same thing, specifically applying to the mind itself. As a concrete example, if someone asks you if you know what time it is, and you haven't really been watching, but you do have a watch, and so you check your watch, and that tells you what time it is. But do you think the answer to that would be yes or no when they query whether you know what time it is? I would wager that you'll say yes instead of no, even though you haven't checked your watch yet. And that's because an intuitive sense that the information contained in your watch is already in your extended mind. So why am I talking about extended mind? Because the scene spec, this intermediate format, is the extended mind of an artificial intelligence. Its mind is using these intermediate formats as a cache of its thoughts. And just as our tools have made us so much more powerful as thinkers, I think that this intermediate format is doing the same for artificial intelligence. In particular, in today's case, it's the holodeck. It's what's enabling this holodeck to happen. And this intermediate format, this area that the synthetic mind has extended itself into, is also a playground for us, because it's something that we can actually touch and manipulate, as opposed to the weights inside of a neural network. An intermediate format can be easily expressed in a way that makes it approachable and interactable by us. The prototype holodeck viewer that I built is not just another practice project for me to develop my skills or have something to talk about on YouTube. It's at the core of my mission, which is to equip the worthy to thrive in the singularity. And the worthy are the builders with honor, engineers, business leaders, the curious thinkers who want to create a better future, one that is prosperous, truthful, and free. If this resonates with your ideals, then let's connect in our mission. It's you that I'm trying to equip. YouTube is great for sharing a message, but it's offline, off-platform, where we can apply these ideas and actually build something. So, of course, like and subscribe, but also get in contact. You can see my website, which is linked in the description to this video or somewhere below, and get in touch. We should talk.